Hello, Professor Cheban again. In this video, I'll do homework from 6.2. The binomial probability distribution is the topics. First question is, which of the following criteria for the binomial probability experiment? Okay. There are four criteria. The one is the trial are independent. That's the A. Second criteria is let's just say the probability. You can read all of those, you find it. The experiment is performed fixed number of time. That's another criteria. Another criteria is the probability of success is the same for each trial of the experiment. That's another criteria. And the last one is there are two mutually exclusive outcome: success and failure. Okay, two outcome, one is success, other is failure. These are the four criteria for the binomial probability experiment. Question number 2. Determine if the following probability experiment represent the binomial experiment. If not, explain why. Okay, and if it is a binomial experiment, state the number of trial. N is number of trials. Here's the experiment. An experimental drug is administered to 180 randomly selected individuals with the number of individuals responding favorably recorded. Okay, and here we do 180 trial. The number of trial is fixed, correct? And each person has different characteristics. Therefore, whenever you experiment first person, second person, these trials are independent, correct? Because the probability of whatever first person favor or not, it doesn't affect the each second person favor or not. Okay, and therefore trial are independent. Also, you might see that there is two outcome mutually exclusive, either they favor to the drug or not favor to the drug, and that's why all four criteria is satisfied, and then answer going to be yes. A is the answer. Yes, the experiment satisfy all the criteria for the binomial experiment, and n equals to 180 because there is 180 randomly selected individuals. Okay. Question number 3. Determine if the following probability experiment represent the binomial experiment. The similar questions, and here the experiment. 7 cards are selected from the standard deck of 52 cards. Okay, this is the experiment. 7 cards are selected from standard deck of 52 cards without replacement. That's the important word here, without replacement. For example, if you select first card, don't replace it. Number of diamonds selected is recorded. In this experiment, you want to record number of diamond. Okay, now is this a binomial experiment? No, because the probability of success is not the same for each experiment. For example, remember that if you get diamond, that's the success. What's the probability of getting diamond in first trial? How many diamond? 13 divided by 52, right? That many probability to get the diamond in the first trial. In second trial, what happens? In second trial, the probability of diamond going to be either 13 over 51 or 12 over 51. Remember that you draw the card, but you do not replace. There is 51 card on the second trial, correct? But if you draw the diamond in the first trial, your probability of getting diamond is 12 over 51 because there is only 12 diamond left if you draw a diamond in the first trial. But if you do not, the probability of getting diamond in second trial is 13 over 51. Therefore, you see that in the first trial, second trial, probability of success, here success is getting diamond, is not the same. Therefore, this is not the probability experiment. The answer to this question is number 3, C, because the trial or experiment are independent. And also you can see that probability of success is differ from trial to trial. Okay. Question number 4. Determine the following probability experiment represent the binomial or not. This is a similar question 1, 2, and 3. A soccer goalie who stops 44% of his shoots is asked to make save until he give up a goal. Remember that this is not binomial because we don't know how many trials are there, because it says he is asked to save until he give up a goal. Okay, therefore we don't know when he gonna give up a goal. Therefore in this questions, binomial experiment is not binomial because the experiment is not performed fixed number of times. Because in other word, n is not fixed here. It's not the binomial. Okay, question number 5. Suppose you are taking an exam with 12 questions. Okay, and you are required to get 8 or more right answers to pass. Complete the part A through D. You have a different part here. And notice that 12 questions there. Therefore, your number of trial is going to be 12. I should say n equals to 12. Okay. You are required to get 8 or more right answer to pass. Okay. Make sense? Part A. With a 12 questions, true or false, what is the probability that of getting at least 8 answers correct by guessing? Okay, here you go. You have probability in this case in part A, P equals to, this is the probability of success. Okay, and here true or false test, therefore only 2 options, and the probability that you guess correctly is 0.5. That's the P. That is called probability of success is 0.5. And here the question is asking for what's the probability of getting at least 8 correct answer. What do you mean at least 8? Is more than 8. Therefore let's write it down this way. Probability x greater than equals to 8. Here we are using for calculator, using calculator to find this probability, and I want to tell you, you might have this in your notes so they can see what inequality, what function you're going to use for this binomial distribution. Since you are looking for probability of x greater than equals to 8, greater than equals to any number, here is 8, and you are using let's see, this one, see, greater than equals to 8. You're using 1 minus binom CDF NP A minus 1. Let me write down this here. 1 minus binom CDF NP A minus 1. Okay, that's what you're using. Okay, 1 minus, what did I say? Say 1 minus binom CDF NP A minus 1. Okay, now here this is the number of trial. In this case it is 12. This is a P, which in this case this is 0.5. This is A minus 1, and this value is X value, 8 is A. Okay, this value is A. Therefore A minus 1 is pretty much what, 8 minus 1 is 7, because A is 8 minus 1. I should say this is X value, okay, which is equals to A, and A minus 1 is 7. Therefore you have to input this everything in the calculator properly to find this probability. Let me show that for you. It starts with the this whole thing. Start with the 1 minus, okay, 1 minus, I'll teach you how to find binomial CDF, okay? And the binomial CDF is under this VARS. Therefore, you have to press second and VARS, okay? And you scroll down, you'll find binomial CDF here. See, binomial CDF, and enter. You have this binomial CDF starts with the parenthesis. You type the value of n, which is 12. Comma is here above 7. You type probability of success, which is p, lowercase p, it's 0.5, comma, and a minus 1, which is 7, and close the parenthesis and press enter, and you get 0.193847. but if you round it to 3 decimal, I think that's the instruction says, round it to 3 decimal, you're going to be 0.194, okay? 0.194, that's the probability, 0.194. Some of the calculator has this window rather than binomial PDF. You have this window. In the case, you guys just do 1 minus, and this row shows up. Number of trials, you put 12, p value put 0.5, x value you put 7, and do paste and enter. You get exactly the same thing here, and you get the answer. Therefore, depends on the calculator. If you have a calculator, other type of the calculator, not like mine, like like mine, but different version, you type 1 minus binomial CDF, but you'll see that number of trials, you know, p value, x value, option. You got to put this value and paste and enter. You get same answer. Okay, this is exactly similar way you do it. Okay, I answered the first question. Let's answer the second question. Part B. Part B is similar. What's the difference, part B? Let me change to the part B. Part B, you're doing exactly the same thing, except in part B, there's 12 questions, multiple choice test with 4 possible choices for each question. Right? What is the probability getting at least 8 answers correct by guessing? Only one of the choices is correct for this question. Therefore, in this case, in the second question, the probability of you answer correctly is not 0.5 but 0.25, pretty much 1/4, right? Because there is out of 4, 1 is only correct answer. See, only one of the choice is correct for each question. This is exactly similar, except you put 0.25 here, right? 0.25 rather than 0.5 is 0.25, 0.25. Does it make sense? Again, the same. This is the same thing for B. You find probability of x greater than equals to 8, which is at least 8, right? What's the probability of getting at least 8, right? And let's do the math here. Let's see what happens. You do same thing. 1 minus second VARS, and you find binomial CDF in this window here, this B option, binomial CDF, enter, and you type 12 questions, comma, 0.25 is the probability of success, comma, 7, enter, and you get answer 0.0027, but if you round it to 3 decimals, it's going to be 0.03. As for this, is going to be 0.03. Okay, now let's see. Other part of the question, part C, is with the 12 question multiple choice test, same thing. There are 5 possible choices for each question. Remember that. Rather than 4, you have 5 possible choices. and only one choice is correct for each question. And this is going to be similar, but the probability of success is going to be 0.20, right? 0.20. Why? Because out of 5, only one answer is correct. Therefore, the same is 1/5. See, 1/5 the probability of success, because there is only one correct answer out of 5. And same idea here. What's the probability of getting at least 8 answers correct by guessing? All similar, except this probability is going to be not 2.5, but 0.20, right? 0.20. And do the math here, do the exactly same, and you get the probability 0.001. And what do you notice? Okay, what do you notice? In first case, if true or if there is a all true or false question, probability that you answer at least 8 questions correctly is 0.194. If there is a multiple choice test with 4 choices, only one correct answer, the probability is 0.003. And if there is 5 choices with only one correct answer, probability of getting at least 8 answers correctly is 0.001. That means first case the chance of passing is 19.4%. Second case probability of passing is 0.3%. Third case probability of passing is 0.1%. Okay, then what do you think? Which test would be easiest to pass by guessing? Of course, true or false test. The true-false test. True-false test. It would be easiest to pass by guessing, since the probability of getting at least 8 answers correct by guessing on the test is greatest. And the multiple choice test with the 5 choices, not the 4, is the hardest. Multiple choice, the 5 choice is going to be the hardest, because the probability of getting at least 8 answers correct by guessing on that test is least. Right? That's the question number 5. Question number 6. In certain state, 45% of the students indicate that success is their favorite pizza. Suppose the simple random sample of adults in the state of 25 size obtained, and the number of adults who indicated the success is their favorite pizza was 17. Remember that 25 is number of trial. We asked number of trial. We asked 25 people, and we found that 17 people like success as their favorite pizza. Therefore, X here is 17. This is number of success. And what's the probability of success? Probability of success here. Success here is who like success pizza. Okay. Success is going to be 0.45. Because remember that 40% like indicate that success is their favorite pizza. Okay. Therefore, probability of success is 0.45. That's the answer for question number 6. Question 7. The binomial probability experiment is conducted with the given parameter. It says this is the binomial probability experiment. Compute the probability of X success in the n independent trials of the experiment. Here n, p, x are given. You got to find p of 5. P of 5 is same as p probability of x equals to 5. Notice that this p here is lowercase p. This p here is uppercase p. That represents probability x equals to 5. Okay, and to do that, let's go back to the function, and here is the function probability x equals to 5, which is the one we're using. Binomial PDF. Notice that everybody has CDF here, right? Except this equal has a PDF. Binomial PDF NPA. Let's do that. Binomial PDF. Let me write down here. Binomial PDF NPA. What's the N value? 7. What's the P? 0.45. What's the A? 5. Notice that everybody has a value, and you got to put in the calculator. Now again, you go to the calculator, you do second, and you do VARS, find binomial PDF, which is just next to CDF, above CDF. Okay, here you go. See, binomial PDF, which is A, highlight A, click, and you put the number. Number of trials is 7, comma, lowercase p is 0.45, that is probability of success, comma, number of trial, that means x value is 5, enter, and you get 0.11722, and you think rounded to 4 decimal places, I guess. And it's going to be 0.1172. Okay, that's the answer. Okay, you can do question number 8 by yourself. Let me do question number 9, but similar to 8, but I can do that. Here similar, n is given, number of trial is given, p equals to 0.2, probability of success, x less than 4. You're looking for probability of x less than 4, x less than 4, and you're going back to the list of the function, x less than 4, you're using this. And what are you using? Binomial CDF NPA minus 1. Let's use that. Binomial CDF, binomial CDF, binomial CDF NPA minus 1. Here A is 4, right? This is, well, let me put the value of n. What's the n going to be? N going to be 8, P going to be 0.2, A minus 1 must be 4 minus 1, which is equals to 3. Therefore, I got to put this values in this calculator in binomial CDF function. Let me do that for you. You goes second, VARS, scroll down, find B, which has binomial CDF, enter, and let's put the value n p a minus 1, which is 3, 8 comma 0.2 comma 3, close the parenthesis and press enter. You get 0.9437. Okay, that's the answer, 0.940. Okay, question number 10. According to the recent poll, half of all pet owners would get their next dog or cat from the shelter. Make sense? Consider the random sample of 10 pet owners. That means here number of trial is 10, and X as the number of pet owners who would require their next dog or cat from the shelter. Remember, the X is the number of pet owners who would require their next dog or cat from the shelter. Assume X is the binomial random variable. Complete part A through F. For the binomial experiment, define success. Again, success is the pet owner who would acquire their next dog or cat from the shelter. Remember that X is the number of success, the number of pet owners who acquire their dog or cat from the shelter. That's going to be X. Therefore, success is the pet owner who would acquire their next dog or cat from the shelter. For this binomial experiment, what is n? 10, because we get the sample of 10 pet owners. What's the probability of success? Is half, 0.5, because it says half of the pet owner would get their next dog. See, half of the pet owner would their next dog. The probability of success is half. Find p x equals to 6. To find this d, you have to do binomial. This is pretty much x equals to 6, right? The probability of x equals to 6. See this here. You see that here. And again, we did that. What's the formula? Binom PDF n p a. What's the n value? N is 10, p is 0.5, a is 6. Okay, use that on the calculator we did before. The answer must be 0.205. Okay, for E, find px greater than or equals to 3. Use this function 1 minus binom CD of np a minus 1, as you did in this question before. You get the answer for this question as well, which must be 0.945. For part F, for greater than or equals to 8, okay, we have the formula for that, or function for that. Px greater than or equals to a gonna be 1 minus binom CDF n p a. That's the formula or function. Here, what is the value of a? A is 8, n is 10, p is 0.5. And if you put that in the calculator, you get the answer for this one. Let me put that for you. Always starts with the 1 minus. But you're putting this all in the calculator. All this together. You're putting all this all in together in the calculator, because calculator does the calculation for you. Start with the 1 minus. Now let's find binom CDF under second PARS, and you'll find a binom CDF in the option B. It's binom CDF, enter, and let's type 10 comma here 0.5 comma and 8, close parenthesis, and that's where you type everything as it is and press enter. You get 0.0107, but rounded to 3 decimal places, going to be 0.011. Okay, the answer is 0.011. Question number 11. According to the government data, the probability that an adult was never in the museum is 15%. 15% is the probability that adult was never is in the museum. Okay, they were not in the museum. That means 50% adult never been in the museum. In the random sample, in the random survey of 10 adults, what's the probability that at least 8 were in the museum? Okay, that means we're looking for probability of at least 8 means greater than or equals to 8 in the museum. Notice that this at least 8 is x is bigger than or equals to 8. Were in the museum. Okay, if 15% were not in the museum, then how many were in the museum? 85%, right? 85% were in a museum. Okay, here the probability of success is 85%, which is going to be p equals to 0.85. Okay, but remember that this 15% is not the probability of success, because if you look at the question, out of 10 people survey, what's the probability that at least 8 were in the museum? I'm looking for the probability that the person were in the museum, which is 0.85. And if you go back to the list of the function over here, we're using probability of x greater than or equals to a, 1 minus binomial CDF NP a minus 1. That's what I'm going to use. Okay, remember that this has to be handy for every time when you do this question from this section. The 1 minus binomial CDF n is 10 p 0.85 comma, and notice that we use a minus 1. Notice that a is 8, a minus 1 is 7. Okay, 7, and you put that everything in the calculator to get the answer. Here's your calculator. You put in all this in the calculator. 1 minus binomial CDF 10.857, and you do 1, the minus, second BRS, and binomial CDF is under B here, and enter, and you have to put 10 comma 0.85 comma 7 close parenthesis. That's the everything over here. Press enter, you get 0.82019, and for the question asks you to round it to 3 decimal, and the answer must be 0.820. okay, that's the answer. Question 12. According to the Federal Communication Commission, 70% of the US household has DVD player. Okay, 70% has a DVD player. In a random sample of 15 households, what's the probability that the number of households with a DVD player is between 10 and 12 inclusive, round to 4 decimal places? Here we're looking for this probability of the number of people who has a DVD between 12 and 10. Okay, that's what we're looking for. Okay, all right, this is the word we're looking for. And if you look at this formula here, we have the formula for this, our calculator function, binomial CDF NPB minus binomial CDF NPA minus 1. Okay, let's write down the formula. Here, binomial CDF NPB minus binomial CDF NPA minus 1. Notice that B here is, that's 12 is a B and 10 is a A. Okay, and here if you write in the formula, this must be, B must be 12. Okay, because B's value is 12, and the A minus 1 must be what? The A minus 1, this A is 10, the A minus 1 must be 9. Therefore, we got the 9 here. But what's the N here? What's the N value? N value is 15. N is 15. What's the P value? P value is 0.70. Same thing here. N is 15. P value is 0.70. Of course, this is the 9. Okay, let's put that everything in the calculator. Let's just type everything in the calculator. Notice that sometimes you might have this option. Again, I mentioned before, if you have this type of option, you put number of trials, P value, and X value is going to be the third value. Okay, and the binomial PDF or CDF, your first value always going to be number of trial, second value going to be probability of success P, and X value is the third value. Therefore, in this problem, if you have the calculator of this type of window, you have to type, this is the number of trials, this is the P value, this is the X value. Okay, here number of trial, P value, and this 9 is the X value. That's it. Okay, let me type this whole thing in the calculator, this whole thing in the calculator once. You don't have to do step by step, just do once. Okay, let's start with the this binomial CDF, second BRS binomial CDF is here. You have n 15 comma 0.7 0 comma 12 parenthesis minus binomial CDF again. Now let's type this one, minus second BRS. Let's find it. Binomial CDF is here, and 15 comma 0.70 comma 9 its value. Okay, enter. I'm sorry, close parenthesis and enter eventually, and you get the answer 0.59479. But if you round it to 4 decimal, it's going to be 0.5948, and the answer is going to be 0.5948 here. Okay, the answer is 0.5948. Number 12 is done. Question number 13. At the question number 13, use the applet. Well, I'm going to show you MyLab math homework here, but that's the question number 13 looks like. Okay, let me scroll down here. That's the question number 13, and that's the applet link here, and it says use the binomial distribution applet to answer part A through D. Here's the binomial distribution applet here. It's open like that, and you see that there is a value for n and the value for p, right? Let's move it off here. See the value of n and value of p. Okay, the value of n, value of p. The first question is slide this. Set the slider n equals to 10. We have n equals to 10, and p 0.2. What is this? What is the shape of the distribution? Let's do that. Okay, and let's slide this to look at this p value. Change it when you slide, and this way you can slide to 20, 20, 205, 20. Yeah, pretty much 201 and 20 is similar. But what you notice is the distribution is, you'll notice that distribution is going to be skewed right. Notice that this bar here, and it looks like your distribution is skewed right. Therefore, for n equals to 10, if p value is close to 0, that means shape of distribution is going to be skewed right, correct? And check answer, you get good. And it says, hey, now increase slider to 0.5. The value of p going to be 0.5. What's the shape of the distribution? Let's do that. Here's a p value here. Let's scroll down to 0.5. Okay, remember that n is fixed. Still keep the n 10, but p value changed from 0.2 to 0.50. The probability is going to be like 50%. And what happens? So this is, just think about that. This is like almost 0.50. Okay, but this is the same thing, 0.5. And then look at here. The distribution is what? What do you think? Look at this bar, look at this bar, all sides are similar. It's going to be symmetric Bell set. Obviously you see that here. Okay, remember that n is fixed, but you change this p value 0.5. That's symmetric. And you go to the next question. Now increase the value of p from 0.5 to 0.8. Let's change the p value, make close to 1. What's going to happen? Let's see that. Here you go. P value is this. Listen, n is fixed. Now increase p value 0.8. 0.8 is this one here, 0.80, and then what's the shape of the distribution? And it's going to be obviously skew left now. Okay, skew left. Check the answer. Okay, now next question. Let's say the slider to n equals to 10 and p value 0.20. Right? Let's do that first. Set the slider n equals to 10 and p equals to 0.20. Now increase the value and until it reaches 60. Repeat this process for any value of n. As increases value, what is the shape of the distribution? Listen. What happens here is this. It says you, okay, let's let's put p n equals to 10. You fix the value of p as, let's say, 0.201, doesn't matter, 0.201, the same, pretty much same as 0.20. Therefore, what happens is, now let's increase the value of n until it is 60. Let's value increase, and let's do the 60. What happens? 60. What happens? You see that? N equals 60. Then what happens? Your distribution is going to be symmetric bell set. Okay. Therefore, now this is, if the p value is 0.20, n equals to 10, their distribution is skewed right. You see that? But if you move, if you fixed p as a 0.20, but if you move the sample size to the right, that means if you increase the sample size, remember that, the distribution is going to be more symmetric. Therefore, LS 60, the distribution is symmetric or bell set. And even if you increase more, 60, 70, 80, whatever, your distribution is symmetric and bell set. Therefore, here, now increase the value of n, or repeat this process for any value of n. As n increases the value, what's the shape of the distribution? Is going to be symmetric bell set. That's the answer. Okay, that's the question 13. Let's do question number 14. Okay, is this basically is a part of the question number 13? Actually, part D of this question number 13 is going to be question number 14. And as you know that, describe how the value of n affect the shape of the distribution. The binomial provided histogram. Remember that as a histogram, or we can call binomial provided distribution, and we call as n increases, right? The binomial distribution becomes more bell set. That's the answer. And you notice that previous example, your binomial distribution is more bell set as n increases. Okay, question number 14 is finished. Question number 15. When can an empirical rule can be used to identify the unusual results in the binomial experiment? Why can the empirical rule be used to identify results in the binomial experiment? When and why? That's the two questions here. Okay, this is like definition question. Answer is here D. When the binomial distribution is approximately bell set, about 95% of the outcome will be in the interval mu minus 2 sigma plus mu plus 2 sigma. That means 95% of the outcome will be within that interval. That means within 2 standard deviations from the mean. Okay, and the empirical rules can be used to identify the results in the binomial experiment when this condition meets np and 1 minus p greater than or equals to 10. If this condition meets, if np times 1 minus p greater than or equals to 10, then only you can use empirical rule. Again, empirical rule is the rule which tells you if the distribution is bell set, how much percentage of data lies within certain standard deviation, correct? Here, if the distribution is bell set, about 95% data lies within 2 standard deviations. In other words, 95% outcome will lies in that interval from mu minus 2 sigma plus mu plus 2 sigma. Okay, that's the question 15. Question number 16. According to the almanac, 70% of the adult smokers started smoking before turning 18 years old. Therefore, here 70% is the probability of success, going to be p equals 0.70. Okay. Now compute the mean and the standard deviation of the random variable x. Okay. Here's the formula for mean. Mu of x equals n times p. That's the formula, which is going to be let me write sigma of x. Standard deviation is going to be n times p, 1 minus p, multiply and square root of that. They are the formula for mean and standard deviation of binomial random variable. Okay, this is the mean and this is the standard deviation of the binomial random variable x. What's the n here? N is number of trials, and here is the number of smoker who started before 18 in 300 trials. Remember that 300 trials is number of trials, which is going to be n, 300 trials. Therefore, we put the 300 times the fee is what? 0.70, which is going to be 210. That's the mean of the random variable. And standard deviation is going to be similar formula. Square root of n is 300, p is 0.7, 1 minus 0.7 square root. Okay, you type everything in the calculator. Let me show you how to do it. You do second square, which is going to be, oh, bad. Just let me clear that. Clear it here. Okay, second square root of 300 times 0.70 times, I can do that 1 minus 0.7 is same as 0.3. okay, I can do it directly and close the parenthesis, because you start before the square root you have to close it, and you go to find the square root of everything. It's going to be 7.993. okay, and it's rounded to I think it's rounded here to nearest tenth. Therefore you write 7.9 for standard deviation of the random variable, and mean is 210. okay, alright. Second question, what is correct interpretation of the mean? The correct interpretation is, this is the expected value. Remember that mean of the random variable is also called expected value. We call mu of x is also equals to expected value, e of x, expected value, expected value. Okay, expected value. What do you mean by that? That means we expect 210. okay, we expect 210 adult smoker will have started smoking before turning 18 in the sample of 300. Therefore, the answer is B here. If you read it correct carefully, it is expected that, remember that 210 is expected value, therefore it is expected that in a random sample of 300 adult smoker, 210 will have started smoking before turning 18. That's the answer. Part, would it be unusual, per se, to observe 270 smokers who started smoking before turning 18 years old? Remember that anything outside this, mu x minus 2 sigma x, mu x plus 2 sigma x, anything outside is unusual. Everything outside is unusual. Okay, unusual, unusual, outside, unusual. Everything which is fall inside is not unusual. I should say usual. But notice that there is doesn't say sigma x here, or no x subscript for mu and sigma, but that's the same thing. Okay, what's the mu of x here? Mu of x is equals to 210 minus 2 times what is the standard deviation? 2 times 7.9, right? 7.9, and the other one is going to be 210 plus 2 of 7.9. okay, and this is the upper limit of this interval, which is going to be 225.8. this value is 225.8. I should say this value here is 225.8. I have to calculate this bottom value because 270 is here. 270 is somewhere here, right? 270 is here. Therefore, this 270 value is outside this interval. Okay, see, outside, above this mu plus 2 sigma. Okay, therefore Yes, it is unusual because this is unusual area, unusual site. Therefore, I should say yes, because 270 is greater than sigma plus mu plus 2 sigma. Okay. Question number 17 is similar to question number 16. You can finish yourself. Um, question number 18 is pretty simple. Let me do that for you. A quiz consists of 820 true-false questions. Okay, true-false questions. N equals to 820. If students guess on each questions, what's the mean number of correct answer? Remember that mean is same as n times p. That's the formula we had it before. Remember that mean is n times p. And what's the n here? N is 820. What's the p? Notice that p is a probability of success. If there is a true or false question, if the answer student guess the answer, the chance the student get right is half, right? Going to be multiplied by half, which gives you 410. That's the expected value. Or if you student guess the mean amount of correct answer or mean number of correct answer going to be 410. Okay, again the mean, which is same as mu of x. In other words, this is also expected value. If you have a question test with the 802 true or false question, you are expected to get 410 question correctly. Okay, that's what it said. This is number 18. Number 19. Sorry, number 19 is similar to number 17, 16. You know, similar because you're looking for mean and the standard deviation. Okay, again, what's the formula for mean? Mu of x equals to n times p. What is sigma x? Sigma x equals to np 1 minus p. That's the formula, square root of that again. And what is the p here? The p is going to be 0.78%. It's going to be 0.78. Okay, what's the n? N going to be a random sample of 100 adults. N equals 100. And put that in the formula, you'll find the answer. Okay, let's do question number 20, the last question of this homework. Suppose 27% of the all births in a certain region take place by cesarean section each year. In other words, 27% of the births in certain region takes by cesarean section. Therefore, p here is 0.27. I should say p here is 0.27. And first question, in the random sample of 1,000 births, that means n equals to 1,000. Okay, how many on average will take place by cesarean section? Okay, here average. Okay, question actually find average. Notice that average is a mean, right? Average. Question number 1, A, on average. Therefore, in the first question part A, we are looking for mu of x. Okay, that's same as n times p. N is 1,000 times 0.27, which gives you 270. Therefore, on average, 270 out of 1,000 birth will take place by cesarean section. What's the standard deviation? And its formula is sigma x equals to np 1 minus p n squared of that, and n is 1,000, p is 0.27, 1 minus 0.27, okay, 1 minus 0.27, n squared of that. And if you use the calculator, I showed one before, this is going to be 14.04. Therefore, here standard deviation of in the sample of 1,000 births is 14.04. Okay, now for C, the number of cesarean section births is 95% likely to be interval. Here in this particular question, you're looking for in the interval looking for lower bound and you're looking for upper bound. And see the interval here? There's a parenthesis around here. You guys notice that parenthesis? When you're looking for a lower bound, you're looking for upper bound. Notice that lower bound is going to be mu minus 2 sigma. Lower bound is mu minus 2 sigma. Upper bound is mu plus 2 sigma. Mu plus 2 sigma. Okay? What's the sigma? Notice that sigma is 14.04. I didn't write sigma x here, mu x. No, that's okay. This is same as what? Sigma, and this is same as the mu. All right. Now let's find mu minus 2 sigma. What's the mu here? Let me write here. Mu plus 2 sigma. Mu is 270 plus 2 times 14.4. This gives you 298.08. Okay. And let's find mu minus 2 sigma. Mu minus 2 sigma equals to 270 minus 2 times 14.4. If you subtract here, you get this 241.92. Alright, now this is the upper bound and this is the lower bound. Therefore 298.08 goes here, but you round it to one decimal. Therefore 298.08 going to be 298.1, right? But it's going to be 298.1. And lower bound here, which is mu minus 2 sigma, going to be 241.9. Okay, 241.9. In other words, 95% both are likely to be this interval. This is pretty much empirical rule. Okay, that's all about this section from chapter 6, 6.2. Thank you for watching the video. Bye.